अस्सलाम वालेकुम डियर स्टूडेंट्स। आज का जो वीडियो लेक्चर है, इन दिस वीडियो लेक्चर वी विल डिस्कस द लिक्विड स्टेट। टॉपिक जो है दैट इज द लिक्विड स्टेट। टॉपिक लिक्विड स्टेट, क्योंकि गैसियस स्टेट हमने कंप्लीट किया है, अब हम डिस्कस करने जा रहे हैं लिक्विड स्टेट। नाउ व्हाट आर लिक्विड्स? लिक्विड्स आपको पता ही है कि लिक्विड्स जो होते हैं दे have a definite volume but they do not have a definite shape. They take the shape of the container, and we have the various properties of the liquids such as the intermolecular force जो होता है उनके दरमियान, that is in between the solid state and the gaseous state. Now another point is that the intermolecular forces जो होते हैं वो भी intermediate होते हैं between the gaseous state and the solid state. They show the property of the diffusion, they are less compressible etc. लेकिन हमें liquid state में तीन important properties discuss करनी है. Number first is that's vapor pressure. Number second, that is surface tension. And number third, that is the viscosity. अब हम ये तीन प्रॉपर्टीज अलग अलग से डिस्कस करेंगे. नंबर फर्स्ट इज दैट इज वेपर प्रेशर. अब वेपर प्रेशर किसे कहते हैं? टू एक्सप्लेन द वेपर प्रेशर, लेट्स टेक ए लिक्विड, सपोज वाटर इन ए क्लोज्ड वेसल. सपोज वी हैव द वाटर हियर इन दिस वेसल, क्लोज्ड वेसल, and it is connected with a manometer like this. We have taken the liquid in this. The manometer, it has a mercury column. Mercury manometer जो में होता है that is mercury. So we have a liquid. So we have a liquid in this vessel which is a closed one. Initially there is no conversion of the liquid into the gas molecules. फिर अगर हम इसको ओपन में रखेंगे into the atmosphere or by applying the heat, what will happen? These liquid molecules, they will start converting into the gaseous molecules, and this process is called as evaporation. So we have first the conversion of the liquid into the gaseous form. More and more gaseous form is there, more and more gases are formed, and this process is called as evaporation, and it is shown by increasing the level of mercury in the manometer. Suppose it reaches at a level A, which shows that more and more liquid molecules, they get converted into from the liquid into the gaseous state, which is shown by the increasing level of mercury in the manometer. Now after some time what will happen? That some of the molecules from the gaseous state, from these gases, they will get condenser, they will move back into the liquid state, that is called as the condensation. So first one was evaporation was there. Evaporation, and in this evaporation more and more molecules get converted into the gaseous molecules, which is shown by increasing level of mercury in the manometer. Now after some time what will happen? Some of the gas molecules from these gas molecules, they will start condensing back into the liquid state, which how that process is called as a condensation, and which is shown by decreasing level of mercury in the manometer. Suppose it reaches at a level B, which is shown by the decreasing, which shows that the level of the mercury decreases, which is which is basically the consequence of decreasing of the gas molecules from the gas molecules, and they get converted back into the liquid state. That's called, the process is called as condensation. So we have the second term here that is called a condensation. कंडेंसेशन में क्या होता है कि मॉलिक्यूल्स फ्रॉम द gases move into the liquid, which is shown by the decreasing level of the mercury in the manometer. Now after some time what will happen, the level of the mercury, it attains a steady value. Suppose it attains a value that is the m, it attains a value m, level of mercury in the manometer, which shows that the rate of the evaporation is equal to the rate of the condensation. जितने molecules liquid से convert हो जाते हैं into the liquid, into the gas form, same number of the molecules from the gas, they will move into the liquid. Suppose if we have here 9 gas molecules are there. 9 gas molecules are here. Now if 3 molecules from these 9 they get condensed back, and at the same time 3 molecules from the liquid they get converted back into the gaseous state, and at that time the rate of the evaporation that becomes equal to the rate of the condensation, and at that time the level of the mercury it attains a steady value, it attains a constant value. At that time we see that there is an equilibrium between the evaporation and the condensation, and at this equilibrium is called as the dynamic equilibrium. अब इस डायनेमिक इक्विलिब्रियम में क्या होता है, रेट ऑफ एवापोरेशन इज इक्वल टू रेट ऑफ कंडेंसेशन. एट दैट टाइम जो गैसियस मॉलिक्यूल्स होते हैं वो एक्सर्ट करते हैं प्रेशर ऑन द सरफेस ऑफ द लिक्विड. दैट pressure is called as the vapor pressure. So vapor pressure may be defined as the pressure exerted by the gas molecules on the surface of the liquid at a dynamic equilibrium, that's called as the vapor pressure. So we have the definition of the vapor pressure, that it is the pressure exerted by the gas molecules on the surface of the liquid at dynamic equilibrium. So we have vapor pressure. Vapor pressure, it is the pressure exerted by gas molecules on the surface of the liquid. That's called as the vapor pressure. So आपने vapor pressure याद रखा है क्या? For the vapor pressure we take a closed container. क्यों closed container? क्योंकि अगर हम इसको open लेंगे, the gaseous molecules formed here they get escaped, and so we are not in a position to study the vapor pressure. For this very purpose we take a closed vessel, and one end of this closed vessel is connected with a manometer. Now first case is that liquids, they start, when they gain the energy, they start converting into the gaseous state. This process, the conversion of the liquid into the gas, this process is called as the evaporation, and after which is shown by the increasing level of mercury in the manometer. Now after some time what will happen, the gaseous molecule जो यहाँ पर है, they get condensed back into the liquid state, and the process is called as condensation, which is shown by decreasing level of mercury in the manometer. And after some time what will happen, so there are two processes, one is called as evaporation and second is called as the condensation. And after some time the level of the mercury in the manometer it attains a steady value. अब इसका क्या मतलब है कि जितना रेट ऑफ इवापोरेशन है यहाँ पे उतना ही रेट ऑफ कंडेंसेशन है. So rate of evaporation it became equal to the rate of condensation, and at that time the pressure is dynamic equilibrium, which this state is called as the dynamic equilibrium. And at dynamic equilibrium the pressure exerted by the vapors on the surface of the liquid, that's called as the vapor pressure. And this vapor pressure is the property of the liquids, and this property depends upon the intermolecular forces. So what we have now, the factors which affect the vapor pressure. So we have factors which affect the vapor pressure. Factors which affect the vapor pressure. नंबर फर्स्ट फैक्टर जो है विच इफेक्ट द वेपर प्रेशर, दैट इज द नेचर ऑफ द लिक्विड. अब ये लिक्विड कैसा है? अगर लिक्विड में इंटरमॉलिक्यूलर फोर्स स्ट्रॉन्ग है, एट दैट टाइम वेपर प्रेशर इज वेरी लो. क्यों? क्योंकि वहाँ पर मॉलिक्यूल्स जो होते हैं, लिक्विड के मॉलिक्यूल्स, वो जल्दी जल्दी नहीं कन्वर्ट होते हैं इनटू द gaseous form. So we have the nature of the liquid. More the intermolecular forces, less is the vapor pressure. नंबर 2, टेम्परेचर का क्या रोल है ऑन द वेपर प्रेशर. टेम्परेचर, बाय इंक्रीजिंग द टेम्परेचर, कम टेम्परेचर इंक्रीज करने से क्या होता है कि इंटरमॉलिक्यूलर फोर्सेस जो होते हैं वो ब्रेक हो जाते हैं. तो उससे क्या होता है कि मोर एंड मोर मॉलिक्यूल्स दे गेट कन्वर्टेड इनटू द दिस gaseous form, and hence there is more and more vapor pressure. More the temperature, more is the vapor pressure. More the temperature, more is the vapor pressure. This is about something about the vapor pressure and what are the various factors which affect the vapor pressure. Now we have the second important property of the liquids, that is the surface tension. नंबर सेकेंड प्रॉपर्टी जो है लिक्विड्स की वो है सरफेस टेंशन. Second is that is surface tension. Now what is this surface tension? Surface in a state of tension. Now to explain what is surface tension, for this very purpose we take a liquid in a container. We have the molecules in the block and some molecules they are on the surface. Suppose we are taking the two molecules here. We have to explain what is surface tension. Surfaces which of the liquids, they are in a different situation than the molecules. Surface molecules are in a different situation than the molecules which are present in the block of the liquid. To explain this surface tension, we are taking a liquid and we have here considered the two molecules. One molecule that is present in the block, that is the P molecule, and one molecule that is lying on the surface, that's our R molecule. R molecule and the P molecule. This property is also based upon the intermolecular forces. The molecule P, it is attracted by the neighboring molecules like this. On the right side we have the left side, upwards, downwards, it is attracted by the other molecules. With the result, the net resultant force of this molecule is 0, क्योंकि हर तरह से इसको molecules ने we have surrounded this molecule and they are attracting this P molecule towards itself. With the result, the net force on this molecule P is 0. And it has the least energy. Now the molecule R, which is lying at the surface, it is attracted by here on the right hand side, on the left hand side, but we have the downward attraction of these molecules. Upwards we have the gaseous molecules, but उनका force उतना ज़्यादा नहीं होता है as compared to that of the molecules which are lying below the R molecule, due to which it feels more and more attraction from the downward and it tries to move from the surface into the block, due to which the surface is in a state of tension. Molecules जो होते हैं surface के molecules, all these molecules they have a tendency to move into the block, due to which the surface it gets stretched, and this stretching it gets reduced, and this stretching of the surface layer is called as the surface tension. So we have to define the surface tension. It is the force acting on the surface when the distance between the molecules is, that is the 1 centimeter, when they are 1 centimeter apart. At that time, how much force acts on this surface acting perpendicular to on this surface, that's called as the surface टेंशन. वो सरफेस टेंशन में आपने याद रखा, सरफेस टेंशन से क्या होता है कि जो सरफेस लेयर होती है वो स्ट्रेच हो जाती है. क्यों? बिकॉज ऑफ द डाउनवर्ड फोर्स exerted by the molecules lying in the block to the surface molecules, due to which the surface is in a state of tension, which is called as the surface tension. Surface tension, we have the factor. There are the various consequences of the surface tension. Number first, जो rain drop होता है उसका जो shape होता है, that spherical shape, it is because of the surface tension. Number second, we have the rise of liquid in the capillary. That is the also the consequence of the surface tension. Now we have the factors. Another one, that is the factor which affect the surface tension, that is the temperature. Temperature का क्या रोल है on the surface tension? Temperature का ये रोल है कि अगर हम temperature को increase करेंगे तो surface के जो molecules they gain the energy, get converted into the gaseous state, and due to which the surface tension it decreases. So we have the surface tension. Surface tension में आपने याद रखा कि जो net downward force होता है on the surface molecule, due to which the surface it gets structured, that's called as the surface tension. Now we have the last property of the liquid state, that is the viscosity. Viscosity. विस्कोसिटी में क्या है कि डिफरेंट लिक्विड्स जो होते हैं दे फ्लो with different rates. The rate of flow of some liquids is very high, some liquids is very low. They are moving with a very low speed, while some liquids they are moving with a high speed. Those liquids which move with a high speed, those are the non-viscous, while those which move with a smaller speed, those are called as the viscous liquids. Now जो ये विस्कोसिटी है वो है क्या? वो रेजिस्टेंस होता है किसी भी लिक्विड में, जो इंटरनल रेजिस्टेंस होती है जो इस लिक्विड को फ्लो नहीं करने देती है, उस प्रॉपर्टी को हम कहते हैं विस्कोसिटी. द ऑब्स्ट्रक्शन ऑफ द इंटरनल रेजिस्टेंस, द इंटरनल रेजिस्टेंस offered the internal resistance to the flow of the liquid is called viscosity. Viscosity को हम explain करने जा रहे हैं by taking the liquid in a narrow pipe, where we say the liquid, where we consider the liquid it is made up of the thin layers like this. This is our narrow pipe. Liquid layers, they are moving, they are considered as the layers. Liquid जो हम यहाँ पर लेते हैं, we are considering them as the thin layers, and then the liquid they start moving. The layer which is immediately in contact with the liquid layer which is immediately in contact with the pipe is said to be almost stationary. Is almost said to be stationary. Because यहाँ पर जो force of attraction होता है between the liquid layer and that of the wall, this wall of the pipe, there is more force of attraction between them, which is called the adducive force, which does not allow it to flow. But जो हम अंदर की तरफ जाते हैं towards the center, the speed of the liquid it increases. Now जो ये वो चीज़ जो इसको फ्लो नहीं करने देती है लिक्विड को. फॉर एग्जाम्पल द लेयर विच इज इमीडिएटली इन कॉन्टैक्ट विद दैट ऑफ द लिक्विड द पाइप, this friction is provided by the pipe or the one layer with that of the another layer. That frictional force is called as the viscosity. That viscosity is given by the force, that's the force of friction, that is directly proportional to the what area of cross section, and dx divided by dv. What is this? Dx divided by dv. A is the surface area, dx is the distance between the two layers, distance between the two layers, and dv is the velocity gradient or difference. So अगर हम proportionality को हटाएंगे यहाँ से, it becomes, we have f that is called neta into a dx divided by dv. What is this neta? It's called as a coefficient of viscosity. It's called as coefficient of the viscosity. If we consider the area of the cross section of the liquid is, that is the a centimeter square. Suppose a is 1 centimeter square, distance is centimeter, 1 centimeter. Suppose if we consider that A is the surface area of the liquid, that's called the 1 centimeter square, distance dx is equal to 1 centimeter, and velocity gradient that is equal to the centimeter per second. At that time f जो है that's called the neta, that is the coefficient of viscosity, may be defined as the frictional force provided by the liquid when the liquid has an area of cross section of 1 centimeter and the distance between the two liquid layers, जो यहाँ पर हमने consider की थी liquid layers, उनके दरमियान जो distance है that's called the 1 centimeter dx, and velocity gradient जो है उनका that's called the dv. तो वहाँ पर क्या होता है कि फ्रिक्शनल फोर्स किसके बराबर होता है? कोफिशिएंट ऑफ विस्कोसिटी. तो कोफिशिएंट ऑफ विस्कोसिटी है क्या? फ्रिक्शनल फोर्स होता है कब? when the area of the cross section of the liquid layers 1 centimeter square and the distance is 1 centimeter apart from each other, two layers which are apart from each other, and unka velocity gradient, because they are moving with the speeds, they are moving with various velocities, due to which the velocity gradient is 1 centimeter per second. So this is the coefficient of the viscosity. The coefficient of the viscosity का जो unit है that is the poise. So these are the three important, हमने थोड़ा थोड़ा डिस्कस किया यहाँ पे. वेपर प्रेशर किसे कहते हैं, सरफेस टेंशन किसे कहते हैं, और विस्कोसिटी किसे कहते हैं. This is all about the liquid state, and in the next video lecture we will discuss some other unit. Thank you so much.